All right, so you need help with number 4. Now, last video, I balanced the chemical equation. You can check your answers right now. This is the answer to number 3. Down here, we've got our flow chart, and I'm actually going to leave these things boxed because all the problems we're doing today are going to follow that same pattern. We're going to start in the mass, go up to moles, go over to moles of another substance. So we're just going to keep following the same pattern each time. So our next question is, how many moles of water? So the question mark we need is, let's put it down here. I'll erase this in a second though. We want to know how much water, how many moles of water can form if 113 grams of acetylene, that is the C2H2, is burned. So this is the starting mass. This is what we're trying to find, the number of moles of water. So let's start by writing out what they gave us, 113 grams of acetylene. Now we're starting with grams of acetylene, that's mass. So let's put acetylene, C2H2, on the bottom down here. And you know what we're going to? We're going to water. So let's put water on the other side. Okay, and let's use this to figure out how we're setting up the problem. We're starting here with mass, or grams of acetylene. We need to go up for our first step, up to moles of acetylene. So we know that our first conversion factor number 1, takes us from grams of acetylene to moles of acetylene. And let's go ahead and start by a second conversion factor. We'll fill in the numbers in a second. Our second one goes from moles to moles, and it's moles of acetylene on the bottom, because we want that to cancel out, remember, with moles of water on top. So far, I've just set up the units, and we're going from grams of acetylene up to moles of acetylene, and then from moles of acetylene over to moles of water. Grams of acetylene up to moles of acetylene, moles of acetylene over to moles of water. Now we can fill in the numbers. And when we're going between grams and moles, that is a molar mass problem, so I'll work out how to calculate the molar mass over here. Remember, for the molar mass, we look at the periodic table. We've got 2 carbons and 2 hydrogens. So we look at the molar mass of carbon on the periodic table, that's the average atomic mass, and we see it's 12.01. And we got 2 hydrogens, and the molar mass of hydrogen, the 2 decimal places, is 1.01. 2 times 12.01 is 24.02. 2 times 1.01 is 2.02. We add them up, and you get a nice 26.04. So that's how many grams are in a mole. So this is how many grams, 26.04, goes with grams, 1 goes with moles. So that's that first conversion factor. We've now filled in the numbers with the molar mass. Our second conversion factor is a moles to moles. That means we need a mole ratio. And remember that all mole ratios, the numbers for those, that's when we look up here at that balanced chemical equation you guys did for problem number 3. So we look for acetylene. We look for the coefficient on acetylene. The coefficient that we found for acetylene was 2. Moles of water, we look for the coefficient on moles of water. And that's a 2. Now let's see if we can simplify this. And I'm going to erase this so I have some room to work with in a few minutes. All right, let's see. What cancels out? Well, this grams of acetylene cancel out with grams of acetylene. Moles of acetylene cancel out with moles of acetylene. We set that up each time so it always works out like that. We also see that 2 and 2, those cancel out. That'll make this hopefully pretty easy. Let's see what we're left with. We've got 113 over on the left. Grams of acetylene canceled out. Times 1 is itself, so that doesn't really change 1 and 13 at all. It keeps it the same. That canceled out. 2 canceled out. And we're left with moles H2O. Divided by, let's see everything on the bottom. We've got 26.04, but grams of acetylene canceled out. 2 canceled out. The units here canceled out. So actually, that's all we got left. Everything else canceled out for us. So we can take, let me rewrite that so you can see that clearly. 113 moles of H2O over 26.04. So we can take those numbers and plug them into our calculators. It's a simple division problem. 113 divided by 26.04. And we get 4.339, let's call it quits there, moles of water. All right, and as with all these, last step is looking for significant figures. Go back to the beginning, we had 113 as our measurement, that's 3 significant figures. We need 3 significant figures in our answer, so we will round that to 4.34 moles of water as your answer for number 4. I hope that helped.